Hi everyone, I'm Qin. Today we talk about the expensive AI with a focus on expensibility for large language models. My goal is simple: show you why we need explanations and what can they are and how they help us build better AI. The big question is, can we trust AI? AI can feel like a black box. We put in data and we get an answer, but we don't always know why. Expensive AI is about opening the books, making the model reasoning clear. When we understand why, we can train the system or more fix the mistakes faster and use AI in fast ways. And as for the motivations, large language models like the ones can write or chat are very strong, but their inner paths are hard to see. This will lead to the problem like the bears hallucinate facts or choices that we can't justify. So explainability helps us answer what did the user pay attention to, which input moved the decision, can we detect flaw earlier? So it will help us to build better trust, better debugging, and better fairness. And in that paper, we can they talk about the explanation in two big settings. The first is fine tuning. Another is prompting. That is, we don't change the weight. We steer the model with instructions and examples. For both, we can explain at two levels, the local and the global. First, like a quick map of the models. A base model learns from the huge text data, and then we get an assistant model by instruction training or reinforced learning. That means aligning the model with human feedback. Why this matters? Because explanations can change from bare to assistant, base to assistant. We want to know that what changed and why. Then for the local method, they try to explain one output that have four families like the feature attributions which word or part of the input matter most. For example, think about the ingredients, the lamb, the sheep. And another is the attention based. Look at the attention map to see what tokens look at each other. And another is example based that find helpful examples, counter examples, or even adversarial cases that review model behaviors. The final is the natural language explanations that the model writes a short reason for its answer. That these don't always agree, but together they give a clues. For the attention maps are easy to see and explain with heat map or graphs. Some words mix attention plus gradients to get better signals, but there is a debate. Is attention itself an explanation? It's helpful to visualizations, but it may not tell the whole stories. And for the global explanations, a global talks to ask what does the model as a whole knows. First is a prompting that trains small prompts to test if the layer holds a syntax or fact. Another is neutral analysis, that is find neutral that fear for certain patterns. Sometimes we can name them. And another is the concept-based and views that test if the model use human concepts, search for small circles that do clear tasks. This method helps us from a mental map of the model. Then we need to expanding prompt layer ends. When we prompt a model, the context we give can shape its behaviors. The first is like in-context learnings. That is, a few examples in prompt can change the answer styles. Another is the chain of thought, which is COT. Asking the model to show steps can make reasoning clear and sometimes more stable. Another is representation engineering. People even try to push the model toward truthfulness or safety by steering internal directions. So a prompt are powerful, and so explanations that show how prompt get the model. So in conclusions, we need explanation to build trust, debug models, and reduce harm. And there are local and global tools for both fine-tuning and prompt models. So, but there are no single method is perfect. We can use a mix, give a better pictures. Thankfully,